Okay, let's make a very slight tweak to the previous problem. The only difference is that we've changed the value on the right-hand side of the B constraint. Let me label these constraints A, B, C. That B constraint used to have a 20 there. We changed it to 36. Okay, so kind of comparing it with the previous problem, had a 20 there. And this was the B constraint before. When we change that number 20 to 36, that constraint slides up in this direction. And so now that B constraint is up here, meaning that we want to be below the A constraint, above the B constraint, and exactly on the C constraint. So if we wanted to satisfy A and B, it'd sort of be this region right here. But you'll notice the C constraint that we need to be exactly on doesn't go through that region at all. Okay, and so pictorially, we know that there should be no feasible solutions. These three constraints, it's impossible to satisfy all of those as well as our positivity constraints. So let's see what happens in the Tableau method with this. So I've gone ahead and essentially updated the starting Tableau to have a 36 on the right-hand side. The only other number that changes is this number up here. I'll maybe sort of give you a kind of quick tip as far as, let me pause that. Never mind. I was worried about something that wasn't a problem. There's a little bit of a trick on how to come up with the M's that you get up here. And that is to look at your rows with your artificial variables in them and know that they're going to have to add up to cancel out the negative M's that were here originally. And so essentially you take M times 10 plus M times 36, and those are both going to add up to give you the 46M up here. With this M times this -1, that's going to give you the -1 there. 1M plus 3M will give you the 4M there, and 1M plus 1M will give you the 2M there. And the -2 and the -3 were what were already in that top row. So that's maybe a little bit of a shortcut, but the only two values that changed in our starting setup were this 36, and now that resulting gives us 46M as our starting objective value. Okay, so let's go ahead and do our pivot here. Again, we'll pivot on X2, and we'll do our ratio test. 4 divided by 1/4 is 16. 36 divided by 3 is 12. And 10 divided by 1 is 10. And so last time we had 20/3 here, and that ended up being smaller than 10. And so we pivoted on this row. But now we're going to pivot on this bottom row because we changed the right-hand side slightly. And so now we're going to get this row that we're going to pivot on. Okay, notice we got a 1 there already, so that makes that nice. And so kind of let's draw a line here and then do a line down here, line across here. And so this bottom row is going to stay the same: 0, 1, 1, 0, 0, 0, 1, and 10. Let's go ahead and work on the objective row first. And so thinking about what we need to do to cancel and make this a row of 0, 0. Yeah, I kind of group 0, 0, and 0. I'm going to have to do -4M plus 3 times the bottom row and add it up to the top. Okay, so -4M times 1 plus 2M is going to give -2M. 3 minus 2 is going to give us +1. 0, that's going to leave this as 0. Actually, this column is going to stay like that. 0, this will stay -M. 0, this will stay 0. Actually, this will stay as our other basis column here. And -4M plus 3 added up is going to make this -4M plus 3. We're going to get -40M. Plus 46m is going to leave us with 6m, plus 3 times 10 is 30. Okay, and this is going to be a 1 here, 0 and 0. Okay, before I fill in the rest of it, I'll look at this top row and I'll notice I've got negative 2m plus 1, that's going to be negative. Negative m is going to be negative. Negative m 4m plus 3 is going to be negative. And so all my objective row values are negatives, which for a minimization problem means I'm optimal. Okay, now all I need to do is fill in the right-hand side values. I need to cancel a 3 and a 1/4. So I'm going to multiply by negative 3 for that one and negative 1/4 for this one. So negative 3 times 10 is negative 30, plus 36 is going to leave us with 6. And negative 1/4 times 10 is 2.5, plus or negative 2.5 plus 4 is going to be 1.5. Okay. So let's read off, and maybe I should label my rows here. I guess I'll label them on this side since I've already kind of written over here. Of my basis variables, this last one is now my x2 variable. This one's still SB bar. This one is SA, and this is my Z. And so my solution now, after one iteration, and this is my optimal solution, is that my Z is equal to 6 times a big number plus 30. So I've got a very large objective value. SA is equal to 1.5. SB bar is equal to 6. So I still have an artificial variable value, meaning that I'm violating the B constraint. And then x2 is equal to 10. So I'm no longer violating the C constraint, because now my other non-basic variables are going to be x1, let's see, SB, and SC bar. Those are all going to be equal to 0. So I'm no longer violating the C constraint, but I'm still violating the B constraint, and I'm not doing any of x1 for that decision variable. Okay, but because my objective row is all negatives and it's a minimization problem, this is as good as I can do. And as good as I can do didn't get me into the feasible region, which pictorially, we're not surprised. There's no way to get to the feasible region to satisfy all three of these constraints. And so the moral of the story is when you have a problem with no feasible solutions, the big M method will bring you to a solution that is optimal in the sort of sense of the relaxed problem with the artificial variables, but it will still include those artificial variables in the solution. It won't have eliminated them, okay? And that's how you know that there are no feasible solutions, because if there were any feasible solutions, it would do as much as possible to eliminate this penalty of 6 big M there. Okay, so when there are no feasible solutions, you'll end up with an M still in your objective, and you'll end up with artificial variables still in your solution. That's it for this video. Next video, we'll look at doing this in R, which will rapidly accelerate this process.